Here we have the notes for 9.3.3. And so what I decided to do based off of the assignment, I found an example that was comparable to what we're doing on 88, 89, and 90. So, and this is in the notes that you guys have, so make sure that you have them printed out in front of you or on some sort of a device where you can take notes as well. So go ahead and take a few minutes. Make sure that you read the entire gist of this question. And I think on the next page, we're going to go through and kind of like highlight different things that we need to kind of extract from the question itself. So now would be a good time to pause and go ahead and read carefully the stem of this question. Okay, so on this next screen, I've got the stem of the question written down, and kind of going to color code what I'm doing here. So if we take a look at what we have up at the very top, we've got corn and tomatoes. Okay, so we're going to let corn be identified by, so I'm just going to do some yellow highlighting here so I can kind of focus on my variables. So I'm going to let x equal corn, and I'm going to let y equal tomatoes. All right, so let's keep that organized while we're going through this. Okay, they have a total of 21 acres available for planting. All right, let's see. So up here, we've got 21 acres available for planting. So I chose like a pink highlighter to kind of go with my red here. So I've got my available land. All right, so if I take all of the acres of corn, X, and I add all of the available acres of tomatoes, all planted, then, and they have 21 total acres, they could either use all of it, so it's equal to, or they could use less. They can't use more acres than what they have, though. So I would say the inequality for available land is all of the corn plus all the tomato plants is equal to 21, so they use it all, or it's less than 21, so they could use less. But you can't like start planting in your neighbor's yard. It's their property. Okay, so then the next one, they have many restrictions based on their labor, okay? So they have a total of 150 hours available for planting. Okay, so I chose planting to be orange. So I'm going to go with orange up in the stem, a total of 150 hours available for planting. Okay, so they can use all 150 hours, or they could use less. They can't do more. Okay. All right, so I go down to my question here. So my planting time, they could use, so on the left-hand side, I'll fill it in just a minute. They could use all 150 hours, or they could use less than the 150 hours, just kind of building my inequality as I go. All right, so let's see. We're going to talk about planting only. All right, so the next line, corn takes 6 hours to plant. Okay, so 6 hours for each acre of corn. Okay, corn is X. So 6 hours for each acre of corn. So if I planted 3 acres, that would have taken me 18 hours. So 6 times 3. Okay, plus, because I'm sure we're going to be planting tomatoes as well. So I'm going to go down to tomatoes now. Tomatoes take 10 hours to plant. Okay, so if Y is tomatoes, so it's going to be 10 for every acre of tomatoes. Okay, so now I've got my next inequality. So I've got a 6x plus 10y is less than or equal to 150. All right, let's see what the next little bit of information is. So I'm going to go back to this whole idea of, I already did planting. My next one, I think, is harvesting. All right, so let's find the harvesting information, which I've already color-coded here as green. So let's say Okay, so I'm back up to the total. They've got 130 hours available for harvesting. All right, so you can use all 130 hours, or you could use less than that. So we could use all, so they could use it all, 130, or they could use less. They can't use more than what they have, okay? All right, so then let's go back up to our question here. We're now talking about harvesting time. Okay, so corn, so I'm going to highlight that guy in green also. 4 hours to harvest. Okay, so 4 hours for corn. So I think that's going to give me 4x. So harvesting time for corn. All right, let's see if we can find the harvesting time for tomatoes. Okay, good. So tomatoes, so highlighting in green, 10 hours to harvest. Okay, 10 hours. So plus 10 for the tomato harvesting. All right, there we go. And then let's see. What else do I have? Oh, grocery arrangement. All right, so that looks like it's the only other question that I had from the previous screen. So let's see. A grocery store has agreed to purchase at least 3 acres. Okay, at least 3 acres of tomatoes. All right, so they could purchase 3, or they could purchase more, which is nice. So this is tomatoes. So they're going to purchase 3, but they could also purchase more than that. So we want to be greater than or equal to. And this is tomatoes only. So this is just going to be y. All right, so I think we've got our inequalities now set up for this type of problem. And I think what we're going to do is I'm going to take all of these guys and we're going to graph them. And we're going to see if we can figure out, like, we want to find the vertices. So the vertices are going to be the corners. And the corners are going to give us a good idea of what the Smiths should do. Okay, so let's move on to the next screen. All right, so I've got my inequalities already written up here. And I want to go through and graph these. So I think I'm going to go deal with the red one first. So I'm going to turn this into an equal sign, just so I can get the boundary. And then I'm going to go ahead and solve for y. So if I do x plus y equals 21, subtract the x to the other side. All right, so let's go ahead and graph that boundary. So we're going to start up at 21, and then we're going to have a -1 slope. Okay, so here I've got my graph for my line. Then what I need to do is I need to test a point. You can test any point you want, just as long as it's not on the boundary itself. So I think I'm going to go ahead and test 0, 0. You guys know me. I love plugging 0 in. So I'm going to go and I'm going to check 0, 0. Back in the original, so it's going to be 0 plus 0 is less than or equal to 21. Okay, 0 is less than or equal to 21. That's true. So I'm going to go ahead and I'm going to shade in that direction. Now I'm going to do this a little bit lighter just because, well, I don't know that I can. All right, never mind. I'd like to, but I don't think I can. So I don't want to go past the axes though, because realistically that doesn't make any sense. So they could plant like no tomatoes if they wanted. That's totally okay. They could do all corn, but they can't plant a negative amount of that. So I'm going to start at my boundary and I'm going to go towards 0, 0. I'm going to go this way, but I'm not going to go past that axis because that doesn't make any sense. So 0, 0 worked. All right. Now, since I'm putting so many inequalities on here, I think what I'm going to do as I keep adding new ones on, I'm not going to shade it in darker, so do the crosshatch thing. I'm going to start erasing. So I think it's going to get a little convoluted and kind of crazy in here. So let's go through and do the orange one now. All right, so I'm going to do the same thing. So I'm going to turn it into an equal sign and I'm going to solve for y. So this is actually a good opportunity for you to go ahead and practice this yourself. So I'm going to go ahead and work through it, but if you want to pause and see if you can do it, that would be great. Okay, I'm going to turn it into an equal sign. I'm going to move the 6x over to the other side. I'm going to divide everybody by 10, and I am going to simplify as I go. Okay, so I'm going to go ahead and graph that guy. Okay, so now I've got my graph on here for my orange one, so the orange boundary that I created. All right, well, looks like I can test 0, 0 again, so I'm going to go ahead and do that. So I'm going to check 0, 0, plug it back into the original. Okay, so 0 plus 0 is just 0. 0 is less than or equal to 150. That's true. 0 is less than or equal to 150. Okay, so what I'm going to do is I am going to go from the orange line. So from the orange line, I'm going to go towards 0, 0. All right, so from the orange line. Okay. I'm starting to see where the overlap is going to happen between the red and the orange. So what I'm going to do is I'm going to grab my eraser and I'm going to erase the parts that are only red shading and the parts that are only orange shading. So let's see if we can get rid of those guys. So only red shading. And only orange shading, because I am looking for the overlap between the two. Okay. So now I went through and I erased all of the non-overlapped shading. So I want to go through and kind of do the same thing now. So with the green one, so let's turn this guy into an equal sign. Let's get y equals out of it. Again, great opportunity for you to pause and then see if you can get the same answer. So I don't want to write this too big because I'm getting low on space here. So I'm going to turn it into an equal sign. Move my 4x to the other side. And then I'm going to divide by 10, simplify. So it gives me negative 2/5 x plus 13. Okay, I'm going to go ahead and graph that one now. Okay, so now I've got my green graph on there, and then I'm going to test 0, 0 again. Now, you can always test a different point. That's totally okay. Just make sure that it's not on the boundary itself. So I'm going to check 0, 0, plug that back into the original. I get 0 plus 0, which is just 0, is less than or equal to 130. That's true. So from the green line, I'm going to shade down. Okay, so from the green line, I'm going to shade towards 0, 0. Now, you should start seeing where the red and the orange are overlapping, but the green's not going to overlap. So just want to make sure that I stay below the green line and I want to overlap. So I think I'm going to try to avoid shading extra. All right, so below the green line, but where it's already red and orange. Okay, so below the green line, but where it's already red and orange. So notice I'm not going all the way up to the green line anymore. Only want to go where the overlap is already located. Okay, but there was still red and orange that was there that wasn't an overlap, so I'm going to go ahead and erase that then. So let's get rid of these parts here where there was red and orange, but now no green. So let's erase those guys. Again, it can kind of just get a little crazy looking, especially when you're having this many graphs on the same coordinate plane and with all that different shading. It just gets a little busy, and people I know I do, have a hard time trying to distinguish between, well, what's really the answer and what isn't. Okay. All right, so there we have a nice little region happening. Okay, let's go to the last one now. All right, this one's not so bad. I actually like this one a lot because it's just a single variable. So I know this is just going to be y equals 3. All right, so let's go back to the graph. We'll go to the y-axis where we have 3 here. And then this is just a straight line across. So this is going to be a diagonal line. So I'll go there, straight across. Oh, make sure I stay on the graph. There we go. Okay, so now test a point. Well, I'm going to do 0, 0 again because it's definitely not going through that point. So I'm going to check 0, 0. And get 0 is greater than or equal to 3. That's not true. That's false. So I don't want to shade towards 0, 0, which would be below this line. I want to shade away from 0, 0, which is above this line. So I'm going to go to my blue line and I'm going to shade up. But I'm only going to shade where there's already overlap. Okay, so I'm going to go above the blue line, but only where there's already overlap. And it looks like I'll have to get rid of some extra shading here. So don't go further than you're supposed to. Okay, so where we already have overlap with the other 3 colors, and then I'll go back and we'll need to erase the non-overlapped region. So we'll get rid of the section where there's no blue. Okay, so I erased everything that was kind of extra. So now what I have here is this enclosed region with all of my graphs. This is what we call the feasible region. So this is really the region where the Smiths want to make sure that they're operating under. So if we take a look at this, and then on the previous question, we were supposed to find the vertices. Well, vertices are just corners. So I'm going to go through and I'm going to grab a black pen this time. And I'm going to find where all of these, so if I've got my big shaded region where my corners are located. So it looks like I have a beginning corner at 0, 3. So that's one of my corners there, 0, 3. Let's see. Looks like I also have a corner up here at 0, 13. So I'm just identifying my vertices for this thing. All right. It also looks like I have a corner right here where the orange and the green meet. So that looks like it's at 10, 9, I think. 10, 9. Looks like we have another corner, kind of in this area. Where is that at? Well, hopefully your graph is a little bit better than mine. Let's see. Okay, so I went back and I double checked my points on my graph, and it looks like my red line is off by just a hair. So I went through, so you can see like right there where I just circled in big black. You can see my orange dot from my orange line using slope and my red dot from my red line using slope. It looks like that's where they're supposed to intersect. So that right there is a point. And then looks like my other point is right. Oh, let's double check that. Yep, it's right here. Okay, so now let's see where that questionable point was located. All right, that's at 15, 6. And this last one is at 18, 3. Okay, so now I've got the vertices of my enclosed region. So basically, if I went through with scissors and kind of cut out the shaded region, where would I like stop at on the grid to make sure that when I pulled it out, the only thing I would get is that. So there's my enclosed region, and there are my vertices. And I think now I can answer the next question. So on my next slide here, I went ahead and just grabbed my graph from before, cleaned it up a little bit so I could see it a little bit better. It still has the exact same vertices on it. So now what I'm supposed to do is I'm supposed to figure out how much they should sell of each type. So, or how many acres they should plant so they get the most amount of money that they can. So we know they're going to get $600 per acre for corn. They're going to get $800 per acre of tomatoes. So we think about this feasible region and where all of these vertices are located. These vertices represent all of the possibilities, feasible possibilities that the Smiths should do. So we're going to use those actually to figure out, well, what should they do to try to make the most money out of this? Now, you can check all of the corners, which is what we're going to do. And then the one that gives us the most money is the one that we should do. Another way to think about this is you want to try to maximize the amount of both corn and tomatoes. So keeping that in mind, I'll be honest, I don't think that the 0,3 vertex is going to be good for us, but we're going to go ahead and check it anyway. So I'm going to go through, I've got my vertices that I labeled on the previous slide. So I've got that one is going to be 0,3. So that was my first corner. And then remember that corn is X and tomatoes is Y. So we're going to do $600 for 0 acres of corn, and then we're going to do $800 for 3 acres of tomatoes. So I'm going to take that 0,3 and we'll do 600 for 0 acres of corn, and then 800 for 3 acres of tomatoes. And then I'm just going to go ahead and grab my calculator on that and see what I get. So at this point, I would go through and I would figure out that this is going to give them $2,400. All right, so if they did 0,3, they would get a $2,400 if they were bound by all the constraints that we have here. Okay, so I'm just going to go through and I'm going to keep checking all of my corners. So my next one was 0,13. So I plugged that in, and that's going to give me 10,400. Okay, that's remarkably more money than the other one. So we're definitely not doing 0,3. So I'm going to go ahead and pause and fill out the rest of them. It's the same idea. It's $600 for each corn, and I'm just using the corners. So the ones that I identified on the previous slide. So hopefully we have those written down. I'm going to plug it in and see which one of these gives us the most money. Okay, so based off of my calculations here, I think it's pretty clear which one that they should do because it gives them the most money. So with $13,800, and the $13,200 was pretty good, still $600 off. So they could make more money with the other ones. So let's do 15 and 6. So the last thing we need to do is just kind of write out what the Smiths should do. So over here on the left, kind of a little tight on this screen. So I would say the Smiths should plant, and we decided they would plant 15 acres of 15 acres of corn and what did we decide? 6 acres of tomatoes. Now, let's say that the values were different and maybe they got way more money for the tomatoes, way more money for the tomatoes. Well, then chances are you're going to plant more tomatoes. But in this case, because the corn and the tomato amount of money per acre is so close, we do want to get as much as we can out of both of them. Hopefully this helps with the problem that you guys are going to be doing. So the problem set that this is close to.